All right, today I want to show some energy transformation problems. To set it up, I want to point out that not just springs follow Hooke's law. Some common things you'll see are elastic bands or bow and arrow. Something like a trampoline would follow Hooke's law. All right, and the energy stored in a spring, if it's released, it can be transferred into kinetic energy. Okay, so I got an example here for us, and it's going to apply pretty much everything from Hooke's law so far. So I got 900 newtons of force applied to draw back a 75-gram arrow by 30 centimeters in a bow. We're going to determine the maximum speed of the arrow when it's released. All right, so first thing we're going to need to know is how much energy is stored in the bow. We have this formula. Okay, we know the displacement, but we don't know the spring constant. However, we can find the spring constant because we know the force. We can do F equals kx, and that's going to tell us what the spring constant is. Okay, so we got 900. Put this x in the meters. Okay, and our value of k is going to be 3,000 newtons per meter. All right, that's going to tell us now how much potential energy is stored. All right, I calculate 135 joules. Okay, the maximum speed the arrow could possibly have would be when this amount of energy becomes kinetic. And it'll become the kinetic energy of the arrow. Okay, so we're going to assume EK is 135, and that'll tell us the maximum speed. So for mass, we use the mass of the arrow. Just check it out, it's in grams. We don't want that. We want to divide that by 1,000 to get kilograms. Okay, now this is set up. This is going to tell us our answer here. So I'll just shuffle things around. Don't forget to take the square root at the end. I get a nice number here. I get 60 meters per second. Looks great.